Hello, Science 20s. Today's lesson is going to be a calculation lesson. We're going to look first at concentrations of solutions, and then we're going to start looking at 2 out of the 3 math formulas you're going to need for this. So, if we take a look at these 5 beakers, which one would you say is more concentrated? If you chose the dark beaker, I would agree with you. My guess is you chose the dark beaker because it's darker because it has more particles dissolved in it, meaning more solute is dissolved. Now, if we could go by something other than color, let's pretend these were glasses of blue raspberry Kool-Aid and they were all in opaque glasses so you couldn't see what they were. Is there any other way we could tell? Taste would be an option if we knew for a fact it was Kool-Aid to tell the difference between concentration. The stronger the taste, the stronger the greater than amount of solute dissolved in the water. Again, we will not be touching taste in this class because we're thinking of these as real chemicals, real solutions in the lab. So, when we're comparing these two things, a dilute solution is when we have a low ratio of solute dissolved in the solvent. So, we have, let's say, 3 particles of solute dissolved in water. A concentrated solution is when I have a much higher ratio of solute to solvent. In this case, we have 7 particles. Now, I like this picture. However, I like this picture even better because in this picture, we can see that the solute is dissolved, but we can also see all the little particles of the solvent, in this case, the water. It's more or less the same picture, but in this one, I can actually see the water particles, in this case, the baby circles, actually dissolved there. Now, what we're going to do is we're going to look at these 3 formulas. We're going to use them in 3 very different cases. However, what we're going to do today is we're going to concentrate on the first 2 when it comes to mathematics. When we look at percent by volume, this is when we measure a liquid and it's dissolved in more liquid. Most cases, is how manufacturers do it. So if I was to think of something with a liquid dissolved in a liquid, this could be a cleaning supply where it tells me what percentage of ammonia is in, let's say, Mr. Clean. This could be liquid dissolved in liquid, possibly some sort of alcoholic beverage. What percent of alcohol is in this can of whatever? For parts per million, we tend to use this for very, very small, very diluted substances. In a lot of cases, this could be the toxicity of water. So when we're thinking about, hey, how much mercury is in the water? How much lead is in the water? Lead is in the paint, possibly. Molar concentration is what we tend to use as scientists. This is the one that we use more often in the chemistry lab. We're going to save this one for the next lesson when it comes to the math part. I'm going to clear that little line. Now, here is our first formula we're going to learn today. Again, like always, I'm giving you the formula. The formula is located on page 10 of your data booklet. Again, my recommendation would be to go ahead and highlight this formula in there so it's easy to find. When I take a look at this, when we are trying to find percent volume, we are going to put the volume of the solute, the thing that will be dissolved in the solution, on top, and the volume of the solution on bottom. When you get confused on which number goes where, think of it like this. Bottom is always the bigger number. We're going to dissolve the solute, the substance we're putting in, into the solution, total solution. So bigger number goes on bottom. Well, let's try an example then of this. So here is our example. And my example is, what is the percent by volume of 20.0 milliliters of orange juice concentrate in a total of 55.0 milliliter solution? So first thing I would do is I would look and go, okay, this is the orange juice concentrate in this solution. So this is going to be my V solute. This is going to be my V solution. So, as always, you get 1 mark for writing down the formula straight out of the data booklet. You will then substitute in your numbers, 20 milliliters on top, 55 milliliters on bottom. Don't forget to multiply by 100%. And when I type this into my calculator, you're going to get the answer of 36.4%. So 36.4% of my orange juice solution is actual orange juice. If I take a look, right, 20%, that's less than half of the total 55. So we expected an answer less than half. Does my answer make sense? That I'm going to go back to that many, many times. So let's clear that. And I would like you to copy this example, pause the video, and try this one for yourself. I'm telling you right now, be careful. I snuck something into this question. Okay, I'm going to go through the answer. Question says, what is the percent by volume if 15 milliliters of ethanol is dissolved in 60 milliliters of water? So I'm dissolving this. This is my V solute. Now, some might think that 60 milliliters is my solution, but remember, this is my total solution. I am mixing 15 milliliters with 60 milliliters. So actually, I have 75 milliliters as my V solution this time. If you go back and read the previous question, it was worded very differently. This time we have to add them together because we're adding 15 milliliters of ethanol to 60 milliliters of water. So when I get the total solution, it's going to be 75. Again, you get 1 mark for copying down the formula. We're going to get another mark for substituting in. So we're going to put 15 milliliters on top. That's my solute. We're going to put 75 milliliters on the bottom. That's my total solution. And then we have to remember to times by 100%. I'm going to type this in my calculator, 15 divided by 75, enter, times 100, and we're going to get 20% by volume. Okay, I'm going to clear that. Now, question number 3 is quite different. Question number 3 is going to give us things we haven't had before, and we're going to have to rearrange this formula. So the question says, the percent by volume of DEET in mosquito repellent is 45%. So this is going to be my percent by volume this time. If I have a total sample of 75 milliliters, so this is my V solution, because that's my total sample, I would like to know how much DEET do I have in 75 milliliters. So we know it's roughly 50%. So our answer is going to be roughly half of 75. Okay, we know we're going to be just a little bit higher than 35 milliliters. Now let's prove that actually by doing the actual calculation. So I am trying to find V solute. So again, you get a mark for writing down the original formula. I'm going to remind you again to move the formula around. When you're solving for something and you want it by itself, when you cross the equal sign with another variable, it's going to change floors. So V solution, when it crosses the equal sign, is now going to go upstairs and be multiplied. 100 is now going to go downstairs and to be divided by. So let's write this out again. V solute equals percent by volume times V solution comes up. So we're going to multiply by V solution. And we're currently timesing by 100. So when we cross, we're going to divide by 100. So let's sub our numbers in. We have 45.0% on top times by 75 milliliters divided by 100%. And so when we type this in our calculator, you should get the answer of 33.8 milliliters. If you do not get this answer, please go back and try typing it in again. I'm going to clear this screen. The second formula we're going to learn is, again, on page 10 of your data booklet. This one is for parts per million. This is the one for very, very small substances. So we have parts per million, very, very small. We're going to take the mass of the solute. Again, solute is on top. Divide by the mass of the solution. So smaller number is going to be on top. Bigger number, bigger is always on the bottom. And this time we're going to multiply by, and this looks scary, but honestly, if you want to write this down as multiply by 1 million, because it's parts per million, I am fine with that. If you don't like times 10 to the 6, that's how it's written in your data booklet. But if you want to remember multiply by 1 million, that works as well. So let's clear this. Let's go to our first example. We'll do this one as a group. So a 300-gram sample of tuna oil solution contains 5.4 times 10 to the negative 3 grams of mercury. So very small number. This is my mass of my solute. I know it's a mass because it's in grams. This guy over here is the mass of my total solution. This is my big sample. So again, we're going to copy the formula straight off of page 10 in the data booklet. That's going to be worth 1 mark. We're going to substitute in mass of solute goes on top. 5.4 times 10 to the negative 3 grams divided by 300 grams. And then we're going to times by 1 million. And I like writing it as 1 million myself. Now, if you struggle and you don't know how to type this number in your calculator, type it in as 5.4 times 10, and then there's a little top hat, negative 3. That's how you're going to type it into your calculator. So I'm going to do it with you. 5.4 times 10 to the little top hat, negative 3, enter, divided by 300, enter, times 1 million. And make sure you get all 6 zeros in there. When we are finished, my answer is going to be 18 grams cancel off. My unit is parts per million because both units cancel out. I'm only left with parts per million. So please make sure when you do this, if you didn't get it right, make sure you try typing it in to get 18 parts per million. Okay. One question left. Again, this is one of those questions where it's a little trickier, so write it down. This is one of those go backwards questions. Let's see how you do. When smoking, the concentration of carbon monoxide reaching your lungs is 200 parts per million. So this is a ppm. What mass of carbon monoxide would be present in a sample of air with a mass of 9.6 grams? So this is going to be the mass of my solution. This is how much mass of air I take in one breath. I need to figure out what's the mass of solute in that amount of air in one breath. So the number is going to be smaller than 9.6 because this number is on the bottom, bigger numbers on the bottom. So we are going to solve for massive solute again, which means when we cross the equal sign, this guy is going to change floors, go up. My times by 1 million is going to change floors and go down. So mass of solute equals ppm, and we can abbreviate parts per million, times mass of solution, because it moved up, so we're going to multiply the 2. And then we're going to now bring it across, so we're going to divide by, and I like writing the 1 million better. So you get a mark for your formula, you get a mark for moving your formula, and now you get a mark for substituting in. So we're going to sub in our numbers, 200 parts per million times 9.6 grams divided by 1 million ppm. So ppms cancel. I'm going to type this in my calculator. 200 times 9.6, enter, divided by 1 million. Again, make sure you put in all 6 zeros. And the answer is 0.0019. The only unit left is grams.